Prime factorization and greatest common factor. So Optimus Prime, thanks Optimus Prime, he's sharing that prime numbers have only two unique factors, 1 and itself. Now composite numbers are not like prime numbers. They're if you have more than two factors. And an example for a prime number could be the number 7. The only two factors with 7 are 1 and itself. So they have exactly two factors. Now composite numbers, like we said, have more than two factors, so that would be like more than 2 of Optimus Prime. In other words, at least 3 of these guys. Or a whole bunch. Can you think of an example of a number that has a bunch of factors or more than 2? How about 24? 24 has 1 and 24. It has 2 and 12. 3 and 8. And running out of room, 6 and 4. So a whole bunch of factors for 24. Now the number 1 is very unique because the number 1 only has really one factor. 1. You can say 1 times 1 is 1, but it's the same factor, so they're not unique. So 1 is neither prime nor composite. It's the oddball. Or let's just say you can't fit it in a box. Oh, I better take out this box then. And to explain that a little more, I'm going to say that it only has one unique factor. And there's another number. The number 2 is also unique because it is the only even prime number. 2 is the only even prime number. So all of your other prime numbers are going to be odd numbers. And the reason that is because 2 will go into any of the other even numbers. 2 goes into 4, 2 goes into 6, 2 goes into 8, etc. All right, now that we've talked about primes, we can talk about prime factorization, which is just writing a number with all of its prime numbers multiplied by each other. So it's just a product of the prime factors of a number. Let's go over a couple of steps on how to remember how to do the prime factorization. The first is we want to make a factor tree. And on that factor tree, you can use any factor you want except 1. So make a factor tree, and then I'm going to put never use 1. In other words, if you try to break down 24 and say 1 and 24, you're not breaking down 24 anymore. It's still going to be 24. So the purpose of the factor tree is to get to the prime factors. All right, and then our second step that we want to do, if prime, underline. Because you're only going to be looking at these prime numbers, so we want to underline them to draw attention to them. If prime, underline. And then third step is we want to write the underlined factors with multiplication signs. And we want to use exponents if necessary. And finally, these need to be in order from least to greatest. And then our last step, after we do that, we have all our underlined factors multiplied. We want to double check our answers. So our fourth step is multiply to check. And if it doesn't multiply to give you the original number, then you've missed a factor. If it gives you too big of a number, you've used an extra factor. So always multiply that to check. All right, let's try using our factor tree. Oh, there's our factor tree. So let's say, for example, that we wanted to find the prime factorization of 45. So example, prime factorization of 45. We're going to write down 45. And then my first step told me to make a factor tree, so any two factors I want. I'm going to choose 5 and 9 because it ends in a 5. 5 is prime because its only factors are 1 and 5. And then 9 has some numbers that will go into it, 3 and 3. 3 times 3 gives me 9. Those are both prime. Their only factors are 1 in itself. And then I'm going to rewrite that using... I'm on the third step now. I'm going to write the underlined factors with multiplication signs, exponents if necessary. So I have 3 times 3 times 5, which is really 3 squared times 5. And notice I've written them from least to greatest. I'm going to multiply that to check. So 3 times 3 is 9. And 9 times 5 is 45. So since this multiplies to give me 45, it checks. All right, now we're going to use the prime factorization to help us find the greatest common factor. And the greatest common factor helps us find the greatest number of equal groups. So think about fans at a sports game. We could see how many equal rows we could have that would fit there by using the GCF. So the first thing we'll do is line up the prime factorization of both of the numbers, or if we had 3 numbers, without using exponents. And you can use exponents, it's just easier if you don't. That way you can see the unique factors. And then the second step is we want to circle the factors they both have in common. And then after we've circled those factors, we want to multiply them together, the ones that they have in common. So for example, if we wanted to find the GCF of 44 and 64, we would first write the prime factorization out, so 44 and 64. And I know 44 is 4 times 11. And I know that 4 breaks down into 2 and 2, and I know that 2, 2, and 11 are all prime. So if prime, underline. And then 64 I'm going to break down into 8 and 8. 8 breaks down to 2 and 4. 2 and 4, 2 is prime. And 4 breaks down into 2 and 2. And that 4 is also 2 and 2, and those are prime. So I'm going to write them, I'm on that first step. It says line up the prime factorization of both numbers without the exponents. So 2 times 2 times 11. And then we also have, for the 64, it would be 2 times 2. Actually, there's a lot of 2's. There's 6 of them. And we're going to circle the ones that they have in common. So there's a pair they have in common, another pair, and there is no 11 on the 64, so we're done. And we're on the last step. We want to multiply them. So 2 times 2. Notice I'm just writing that number once. I'm writing the number from the pair once, and that number is written once. And I multiply them together, and I get 4. So 4 is my GCF. Now that way always works. Another way is you could write the factors out for 44 like 1 and 44, 2 and 22, 4 and 11. And if you know all the factors, then this is a good way, because what's the biggest number here that will go into 64? 4. Because 11 won't go and 22 won't go. And 44 won't go. So the biggest one that would go would be 4. That way works if you know all the factors, but sometimes you'll have numbers that you don't know all the factors for, and it's probably better to use prime factorization. Alright, so what if we have variables though, and we're finding the GCF of those? Well, it's going to be pretty similar. So, for example, say we had 27 x squared y and 126 x cubed y squared, and we were asked to find the GCF. I'm going to look back at my steps, and this first step was to line up the prime factorization. So 27's 3 and 9 if prime underlined. So 3 is underlined. 9 breaks down to 3 and 3. Underline your primes. X squared means x times x. So I'm just going to break those down so they don't have exponents. And then my y is already going to be underlined because it can't be broken down anymore. 126. It's even, so I know 2 will go, so half of 126 is 63. 2 is prime. And 63 is 7 and 9. 7's prime. 9 is 3 and 3, and those are prime. And then x to the third means x times x times x. So I need to write 3 of those out. And then y squared, I'm running out of room, y, and then I underline those. So you're just breaking down the variables so that they don't have any exponents. And now I'm going to line them up. So second step was to write them from order from least to greatest and then circle them, the ones they have in common. So 27 was 3 times 3 times 3. I'm just going to mark those off as I write them. And then times x times y. And then the 126, I'll do that one in red. We had 2 times 3 times 3 times 7 times x times x times x. I have 3 x's. And then 2 y's. And now I'm going to double check that those multiply to give me my numbers. So for instance, 3 times 3 is 9, times 3 is 27. That's what I started with. 2 times 3 is 6. 6 times, I'm going to do 6 times 7 is 42. And then 42 times 3, well, I know 40 times 3 is 120. So then it's just 3 times 2, which is 6. So yeah, 126. They check. All right. And now I circle the ones they have in common. So I see a pair of 3's, another pair of 3's, and the 2 and the 7 don't match up, but I see a pair of X's, another pair of X's, and a pair of Y's. So I'm just going to write that as the number from the factor is 3, the number circled, times 3 times X times X times Y. And that equals 9x squared y. And what we did up to the top, just to explain that, the x squared, we wrote that as repeated multiplication. The x to the third, we wrote as repeated multiplication. So that's what we want to write down. We want to factor the variables with exponents as repeated multiplication. All right, you should be on your way to prime factorization, GCF. You should be ready to rock it. So rock on with your bad self.